So you have the definite integral of sine x minus 2x divided by pi dx. When you have absolute value function, the absolute value has a different behavior. The absolute value of u is, if your u is positive or 0, you get your u back. But if u is negative, you have to put a negative sign in front of u to get something positive out of your absolute value. To analyze this definite integral, since you have absolute value, the best way is to visualize this, right? What's the visualization look like? So first of all, you have your sine function, which we all know how it oscillates. But please note that here you have a range 0 to pi. So we don't have to go further. This is the behavior of my sine function, 0 to pi. This is my sine function. Well, the other function is 2x divided by pi. Forget about this negative sign. Just focus on 2x divided by pi. This is just an increasing line. At 0, you have 0, but if you plug in pi over 2 into the line, 2 over pi times pi over 2, it becomes 1. It means that they have an intersection. The sine function and this line, they are intersecting at pi over 2. Well, based on these, we can analyze the behavior of absolute value. Why is that? On the left-hand side, the sine function is the larger value, sine of x. So sine x minus 2x divided by pi, you can see this value is positive value. Sine minus 2x over pi is positive. So you can for now divide it this way. This is the integral of 0 to pi over 2. Your goal is to get rid of the absolute value. How to get rid of absolute value? As long as you have a positive value, the absolute value disappears. Remember the definition of absolute value. As long as your quantity is positive, the absolute value vanishes, it disappears. So you get your sine x minus 2x over pi dx. But on the second part, on the second half, the line, which is 2x over pi, has a larger y value, and your sine x is down here. So if you look at the area between these two, the larger y value is 2x over pi, right? So the second integral is the integral pi over 2 to pi. The larger y value is 2x over pi. Minus the smaller y value, sine x. So we divide this integral into the summation of two integrals. Now we can do the calculation. This is equal to the integral of sine negative cosine x, and the integral of 2x divided by pi is minus x squared over pi. And x ranges between 0 and pi over 2. Plus the second integral, you get x squared over pi plus cosine x. X ranges between pi over 2 to pi. So if you plug in pi over 2 here, this becomes 0 minus pi squared over 4 pi minus, if I plug in 0, I get minus 1. And if you plug in 0 for x, it is just 0. So I didn't write down 0 on the right-hand side. Plus, if I plug in pi here, we get pi squared over pi plus cosine of pi, which is negative 1. minus, now plug in pi over 2, you get pi squared over 4 divided by pi, and the cosine of pi over 2 is just 0, so I'm not going to write it down here. So let me move this a little bit up to avoid any confusion. What is this? Okay. So this guy becomes, here you have negative pi over 4 plus 1, and here you have plus pi minus 1 and negative pi over 4. So if you combine these two, this is just 0, you get pi minus pi over 2, or pi over 2 is this definite integral. So when you have absolute value, try your best to visualize the absolute value. Whenever your u is positive, you get your u back. The absolute value just disappear, right? So that's why I divided that into two pieces. So I can see on top, I have a positive, I have a larger y value, and my smaller y value is down here. But after pi over 2, my larger y value is this line, and my smaller y value is this sign. So if I subtract sign from 2x divided by pi, this y is positive. And I can get rid of the absolute value by rewriting it as 2x divided by pi minus sine x. So absolute value and integrals, including absolute value, are usually a little bit more confusing for students. But by practice, we can feel more comfortable about these contents.